Good evening to everyone.
Good evening, ma'am.
In previous class, we have learned about the continuity of complex valued function. Today, I will start with the uniform continuity. Uniform continuity. Basically, when we are discussing about the continuity, so actually we discuss the function is continuous at a particular point. But this topic, uniform continuity, is more generalized than continuity, because here we will not talk about only the continuity of the function at a single point. Uniform continuity is discussed for over a interval or over a region. Okay, so it is not only depending upon a particular point. So a function fz is said to be uniform continuous, is said to be uniformly continuous in a region S, in a region S, if for a given epsilon, if for a given epsilon, there exists a real number delta greater than 0. This real number is only depend upon the epsilon which we are choosing. It does not depend upon a point where we are discussing about the continuity, as we have know in the previous topic continuity, where the value of this delta is also affecting not only by epsilon but also the point where we are discussing the continuity. So here we have to there will be exist for a given epsilon greater than 0, there exists a positive delta depending only on depending only on epsilon, such that if we are choosing 2 points z1 and z2 in this region S, so difference of their images at z1 and z2 is less than epsilon whenever z1 minus z2 here I am writing z1 minus z2 mod is greater than 0. Greater than 0 is because z1 and z2 are two different points, they are not equal. Z1 the point z1 z2 which is chosen from this region S, this z1 and z2 are not equal. That's why this modulus is always greater than 0 and less than delta. So where z1 and z2 are two different points, where z1 and z2 are 2 points in region S. These are 2 points in region S. So if for a particular epsilon we are getting a delta which is only depending upon this epsilon, so if mod of z1 fz1 minus fz2 is less than epsilon, only when distance between this z1 and z2 is less than delta. So इस तरह से अगर हमारे पास z z1 है, कोई भी z z1 any z1 z1 and z2 in this S whose distance is less than delta. जैसे ये हमारे पास a region, we have a region S. Suppose that it is a region S. So if we are choosing any z1 z2, it is not these are only z1 z2. Any other point z3 z4 भी ले सकते हैं, z1 dash z2 dash भी ले सकते हैं, but condition is only that distance between this z1 and z2 is less than delta. If it is z1 and it is z2 and their difference, modulus of their difference is less than delta, then difference between their images fz1 and fz2, this must be less than epsilon, where this delta is depending on this epsilon. If this epsilon is getting small, then correspondingly this delta will also change. Accordingly, this delta will also change. It is not depending upon only the z1 and z2. It is saying that we can choose any z1 z2, we can choose z1 dash and z2 dash some in these regions. So if distance between this z1 dash and z2 dash is also less than delta, then again their images, difference between their images is also less than epsilon. Okay, so this concept is called uniform continuity. This is called the uniform continuity. अगर हम मान लीजिए किसी एक कंटिन्यूअस सिंपल कंटिन्यूअस फंक्शन की बात करते हैं, तो कोई अगर हम z1 चेंज कर रहे हैं तो करस्पॉन्डिंगली डेल्टा अगर हम एप्सिलॉन सेम ही रखते हैं, तब भी हमारा डेल्टा जो है वो कोई और वैल्यू ले सकता है, इट मे बी चेंज. बट हियर अगर हमारा एप्सिलॉन फिक्स है तो करस्पॉन्डिंगली उसके डेल्टा सेम ही रहेगा पूरे रीजन के लिए, पूरे रीजन एस के लिए. सो इट इज कॉल्ड यूनिफॉर्म कंटिन्यूटी. एक इसमें इंपॉर्टेंट थ्योरम है, इफ फंक्शन इज यूनिफॉर्म कंटिन्यूअस ओवर द रीजन एस, या किसी भी रीजन एस में अगर फंक्शन यूनिफॉर्म कंटिन्यूअस है तो वो रीजन वो फंक्शन वहां पे कंटिन्यूअस भी होगा. सो एवरी यूनिफॉर्मली कंटिन्यूअस फंक्शन इज आल्सो continuous in that region. But if the function is continuous in a region, it doesn't imply that function will be uniformly continuous. It means that uniformly continuous, this property uniformly continuous implies continuity, but continuity doesn't imply uniform continuous. Okay, so अगर function continuous है uniformly तो it must be continuous. But if a function is not uniformly continuous, yes, a function is continuous, so it doesn't imply that it must be uniformly continuous.
एक्सक्यूज मी मैम.
Yes.
मैम इसका कोई एग्जांपल देंगे क्या? ये
एग्जांपल्स बताएंगे, रुक जाइए, एक थ्योरम बता दें फिर एग्जांपल्स भी बताएंगे इसको. सॉरी. Let, this is the important theorem, proof nahi hai, only theorem is quoted here. Let fz be a continuous function on a closed and bounded set, closed and bounded set S in complex plane, then fz is uniformly continuous. जनरली कंटिन्यूटी हमारी जो है वो इंप्लाई नहीं करती यूनिफॉर्मली कंटिन्यूअस को, बट इफ फंक्शन इज कंटिन्यूअस ओवर द क्लोज एंड बाउंडेड सेट, देन इट मस्ट बी यूनिफॉर्मली कंटिन्यूअस. उस केस में ये यूनिफॉर्मली कंटिन्यूअस भी हो जाएगा. ठीक है. एक इसका एग्जाम्पल जो प्रीवियस वाला हमने बोला था, you know that if we are considering a function fz is equal to z square, we have a function fz is equal to z square, which is defined over the for all z in complex plane, for all z in the complex plane. So you know that it is simple algebraic function, या इसको as a polynomial of degree 2 भी consider कर सकते हैं. So this function is entire function. Entire function means a function which is चलिए differentiability की अभी बात नहीं की तो entire function नहीं बोलते. So this function is continuous everywhere in finite complex plane. Fz is equal to z square is continuous over complete finite complex plane. But this function is not uniformly continuous on C. ये पूरे होल प्लेन सी में दिस फंक्शन इज नॉट यूनिफॉर्मली कंटिन्यूअस. हालांकि ये कंटिन्यूअस है सब कहीं ओवर सी, बट अगर इसी रीजन सी में बात करें तो दिस फंक्शन इज नॉट यूनिफॉर्मली कंटिन्यूअस. इसका प्रूफ है, लेकिन ये प्रूफ में सीक्वेंस वगैरह लेके काफी बड़ा सा है, तो इस सीक्वेंस वगैरह और Z1 Z2 वाली अभी बतानी पड़ेगी. तो सीक्वेंस की कंटिन्यूटी की अभी हमने बात नहीं की है, इसलिए उसको हम यहाँ पे नहीं प्रूफ कर रहे हैं. बाद में अगर कभी टाइम मिला तो हम इसका प्रूफ बता देंगे. अगेन one more question related to uniform continuity. Show that fz is equal to z square is uniformly continuous in region is uniformly continuous इन रीजन. अभी देखिए हमने कहा था पूरे ओवर सी प्लेन पे ये यूनिफॉर्मली कंटिन्यूअस नहीं है, बट हियर आई एम कंसीडरिंग द रीजन mod z less than 1. So this is the closed mod z less than or equal to 1. So this function z square which is continuous everywhere, and here I am considering a region which is bounded and closed. क्लोज भी है, बाउंड्री के पॉइंट्स भी लिए हैं, and it is also bounded region. Mod z cannot take any value which is greater than 1. तो इस केस में ये हमें दिखाना है कि ये यूनिफॉर्मली कंटिन्यूअस है. बट फंक्शन fz is equal to 1 by z square. fz नहीं zz लिख लेते, नया फंक्शन. But zz is equal to 1 by z square. This function is not uniformly continuous. Uniformly continuous in region mod z less than or equal to 1. This function is not continuous in this region. Okay. तो यूनिफॉर्मली कंटिन्यूअस है, ये हमें शो करना है. तो लेट वी हैव गिवन any epsilon greater than 0. So we must have to find a real delta greater than 0 such that here I am choosing 2 points z1 and z2 in this region. So z1 square minus z2 square is less than epsilon, and for this inequality we have to find a delta which is depending only on this epsilon, and we will get we have to come on the inequality Z1 minus Z2 is less than that delta. Okay, so such that Z mod of Z1 square minus Z2 square less than epsilon whenever Z1 minus Z2 is less than a delta, and where this delta depends only on epsilon. Okay, not the particular choice of this Z1 and Z2. Okay, so we will start from this inequality. Z1 square minus Z2 square. This can also be written as Z1 minus Z2, Z1 plus Z2, which is equal to Z1 minus Z2 and Z1 plus Z2. By triangular inequality, we can write here Z1 minus Z2 mod of Z1 plus mod of Z2. Okay, you know that this Z1 and Z2 are the point comes from this region, which is the uh, unit closed disk about 0 of radius 1. So mod of this Z1 cannot be greater than this one, and mod of this Z2 is also always be less than or equal to 1. So here we are using the upper bound. It will give you mod of Z1 Z2 1 plus 1, which can also be written as 2 Z1 minus Z2. Okay, so we are using it. So we will come, we have to, this quantity should be less than epsilon.
Please
हमने
show the
epsilon
previous
लिया है.
slide.
अच्छा, previous slide में 1 second.
Okay, ma'am. Thank you, ma'am.
Okay, so we will come here. 2 times mod of Z1 minus Z2 is less than epsilon. So Z1 minus Z2 should be less than epsilon by 2. So here we will choose delta is equal to epsilon by 2. So let us choose here, let us choose delta is equal to epsilon by 2. So delta is equal to epsilon by 2. So for this choice of delta, we have Z1 square minus Z2 square is less than epsilon whenever Z1 minus Z2 is less than delta, where delta is epsilon by 2. Delta is depending upon this epsilon. And this quantity is greater than 0 because Z1 and Z2 are two different points. Z1 and Z2 are two different points. That's why their modulus is greater than 0. So obviously this function fz1, fz. So obviously this function fz is equal to z square is uniformly continuous on this region mod z less than or equal to 1. Okay. Next is we have to show that zz 1 upon z squared is not uniformly continuous. This quantity is not uniformly continuous. ओके, तो इसको दिखाने के भी कई तरीके हैं हमारे पास. एक पर्टिकुलरली हम ले लेते हैं zz is 1 upon z square. Choosing 2 points z1 and z2 not equal to, in this region mod z is less than or equal to 1. Okay. So again we, for a given epsilon greater than 0, we have to find a delta greater than 0, and this delta is depending upon only on this epsilon. Okay, so we have to take gz1 minus gz2, which is equal to 1 upon z1 square minus 1 upon z2 square. One upon this z1 square upon 1 minus z2 square. Now this can be write as z1 square z2 square, and in denominator this will be, in numerator it will be mod of z2 square z1 square. Again this can also be write as z2 minus z1 and z2 plus z1. z1 square z2 square, and by triangular inequality this can also be write as z1 mod of z2 mod of z1 z2. We can write in place of z2 minus z1 is always equal to z1 minus z2, so it doesn't make any change. Z2 square. Okay, so our reason was z1 is less than or equal to 1, z2 is less than or equal to 1. Okay, so here we can write in place of it mod of z1 1, and plus in place of this mod z2 we can also write here 1. So this will give us 2 times z1 minus z2 upon z1 square z2 square. Okay, so you can see here, because uniform continuity is not depending upon which point we are choosing. It is not depending upon the point which we are choosing. It only says that distance between these 2 points is small. It is a very small, and that small distance is depending upon this epsilon. So in this reason, because this is a closed disk around origin, so for suppose that if we are choosing a point either from this z1 and z2, इनमें से कोई भी एक हम अगर चूज कर लें which is very very close to 0, if we choose either of these 2 points z1 or z2, one point is getting very close to 0, so what will happen? अगर हम ऐसा चूज कर लेते हैं पूरे इंटरवल में, बिकॉज यूनिफॉर्म कंटिन्यूटी है पूरे रीजन के लिए, एक एप्सिलॉन के लिए एक ही डेल्टा मिलेगा. इट इज नॉट डिपेंडिंग कि कौन सा पॉइंट हम ले रहे हैं, बस रिस्ट्रिक्शन क्या है कि उन दोनों पॉइंट्स के बीच की डिस्टेंस जो है दैट शुड बी स्मॉल. सो इफ वी आर चूजिंग either of these z1 or z2, any one of them is very close to 0. Either z1 or z2 is very close to 0, so what will happen?
मैम वो इंफिनिटी हो जाएगा.
यस, इट विल बी इंफिनिटी. यानी कि ये जो हमारी जो हमने ये कंडीशन ली है कि अगर z1 और z2 की डिस्टेंस वेरी स्मॉल है तो डेल्टा और इसके बीच में रिलेशन है, तो एक ऐसा एप्सिलॉन मिलना के साथ होना चाहिए कि ये जो एप्सिलॉन डेल्टा पे डिपेंड कर रहा है या कहें डेल्टा एप्सिलॉन पे डिपेंड कर रहा है, तो इन दोनों की जो इनकी इमेजेस की डिस्टेंस है वो भी इस क्वांटिटी से स्मॉल होनी चाहिए. बट इसी रीजन के अंदर अगर हम इनमें से z1 या z2 में से कोई भी एक वेरी क्लोज टू 0 चूज कर लेते हैं, तो ये इनके बीच का जो डिफरेंस है इट इज गेटिंग टेंड्स टू इंफिनिटी. दिस डिफरेंस इज tending to infinity, and which is always be greater than any small quantity. ये हमारा उस केस में उस एप्सिलॉन से ग्रेटर हो जाता है अगर हम ऐसा कुछ ले लेते हैं. तो क्या होगा, इसका मतलब कि हमारे पास जो इनइक्वालिटी है कि मे बी डिस्टेंस बिटवीन दिस z1 एंड z2 इज वेरी स्मॉल, बट difference between their images is not very small. It may increase and tending to infinity. So it means that this function is not uniformly continuation for this choice of Z1 and Z2. It means that here the continuity, the concept of continuity is depending on points also in this reason. So it is not uniformly continuous because this quantity is becoming very large when we are choosing Z1 or Z2 is very close to 0. So this function is not uniformly continuous in this reason. because because of this point z0 is included in this region. अगर इस पॉइंट को हम एक्सक्लूड कर दें, z इक्वल टू 0 को यहां से हटा दें इस रीजन से, देन आवर फंक्शन विल बिकम यूनिफॉर्मली कंटिन्यूअस. मान लीजिए अगर हम ये ले लेते हैं फॉर सपोज, इसी के केस में कहें कि हम रीजन थोड़ा सा मॉडिफाई करते हैं, यहां से ले लेते हैं, इस तरह से रीजन ले लेते हैं, ये ले लेते हैं 1/2 लोअर, जो ये हमारी ये इमेज है इसको हम ले लेते हैं 1/2. तो एज यू नो दैट मॉड ऑफ z इज ग्रेटर देन 1/2. So 1 upon mod z, this quantity must be less than 2. This quantity will be less than, yes, this will be less than 2, and 1 upon z square must be less than 4. इसका हम यहाँ पे यूज कर लें तो हमारा क्या आ रहा था, gz1 minus gz2 less than 2 times z1 minus z2 upon z1 square and z2 square. So this can be write as 2z1 minus z2 into 1 upon z1 square and 1 upon z2 square. z1 z2 belongs to this region. इस region say that it is s. इस region को imply करते हैं तो this value is always less than this 4 and this quantity is also less than 4. So we can write here 2 times z1 minus z2, 4 and 4. कितना हो जाएगा 4 and 4? 16. So total is, it will be 32 z1 minus z2 less than epsilon. So from here we will get z1 minus z2 is the less than epsilon by 32, and we will choose delta is epsilon by 32. So for this reason, if we are choosing epsilon by delta is epsilon by 32, so we can say that this delta is depending upon epsilon and our function is uniformly continuous over this region if we are excluding 0 from this region. अब यहाँ पे हमने annulus region ले लिया है. This is concentric circle of radius 1/2 and this is the circle of radius 1. इसके बीच की distance है, हमारा z यहाँ है. तो now in that case कोई भी z1 z2 you will choose, it will be never tending to, तो ये जो हमारे पास difference आ रहा है, this difference is never tending to infinity. Okay, so in this case we will get a delta which is depending upon only on this epsilon. Okay, so function is now uniformly continuous. तो अगर इस तरह का हमारे पास रीजन है तो ये फंक्शन gz 1 upon z square ये यूनिफॉर्मली कंटिन्यूअस नहीं होगा, लेकिन अगर इसमें से हम 0 को रिमूव कर दें so then this function is will be also uniformly continuous on this reason. Okay, so this is the concept of uniform continuity. Next is differentiability. Differentiability of a function. So like we know about the differentiability function of a single variable in real analysis, same type of differentiability is defined here. Differentiability of complex valued function. Let fj be a function defined in some neighborhood of z0. Let fz be a function defined in some neighborhood of z0. Then say that it is the point z0 and it is a small neighborhood of this function, this point z0, and function is defined. This function fz is defined at every point of this neighborhood. Okay, so function fz is said to be differentiable. Fz is said to be differentiable at z0 if the limit z tending to z0, fz minus fz0, z minus z0 exist and finite. If this limit exists and finite, then we say that function is differentiable at this point z0, and it is denoted by f dash g0 r df upon dz at z is equal to z0. So अगर फंक्शन हमारा डिफरेंशिएबल है, so this limit must be exist. सेम टाइप ऑफ डेफिनेशन हमने पढ़ी थी रियल एनालिसिस में फॉर फंक्शन ऑफ सिंगल वेरिएबल एक्स, एंड इट्स एप्सिलॉन डेल्टा डेफिनेशन में फॉर्म में अगर हम लिखें, so we can write fz is differentiable at z0 if for any given epsilon greater than 0 there exists a real delta greater than 0 such that fz minus fz naught, z minus z naught, लिमिट यहाँ पे क्या थी, लिमिट अगर एग्जिस्ट करती तो उसको हम बोलते हैं f dash z naught is less than epsilon whenever z minus z naught is less than delta. So if this type of delta exists, so we can say that function fz is differentiable at this point z naught. For suppose that, यहाँ पे एक और तरीका लिख सकते हैं z naught पर डिफाइन करने के लिए. मान लीजिए इसमें z naught की जगह कोई भी एक पॉइंट fz केवल हम लिखना चाहते हैं f dash z, so we can also write it z minus z naught की जगह पे इसको लिख दें डेल्टा z. So we can also write it like z is equal to z naught plus डेल्टा z. So इसी डेफिनेशन में रिप्लेस कर सकते हैं या लिख सकते हैं लिमिट z टेंड्स टू z naught की जगह पे लिख सकते हैं हम z minus z naught is डेल्टा z. So we have to write here डेल्टा z is approaching to 0 for function. देखिए z की जगह लिखेंगे z naught plus डेल्टा z minus f z naught divided by z minus z naught delta z. If this limit exists, then we can say that function is differentiable at this point z. Okay. और इस डेफिनेशन एप्सिलॉन डेल्टा डेफिनेशन की बात करें तो दिस डेफिनेशन विल बी लाइक f z naught plus delta z minus f z naught divided by delta z minus f dash z naught less than epsilon whenever delta z is less than delta. So कोई भी डेफिनेशन यूज करें, all are same. Okay. Now a theorem. If function is differentiable at a point z naught, so it must be continuous at that point. डेफिनेशन या कह सकते हैं कि every differentiable function every differentiable function is continuous. Converse is not true. Converse is not true, but if the function is differentiable, it is definitely it will be continuous. So for suppose that let fz is differentiable at z0, then we have to prove that it is also continuous at this point z0. So we can write fz minus fz naught. We can write fz minus fz naught like fz minus fz naught z minus z naught into z minus z naught. We can write in this way. Okay. Now taking the limit both side. Now taking the limit both side. इसे एप्सिलॉन डेल्टा डेफिनेशन से भी कर सकते हो. There is no problem if you are writing it with the help of epsilon delta definition. Taking limit both side, z is approaching to z naught. Z is approaching to z naught. fz minus fz naught. या हम इसे एप्सिलॉन डेल्टा डेफिनेशन से ही लिख लेते हैं. Because function is differentiable at this point z naught, it means that fz minus f dash z naught, z minus z naught, f dash z naught will be less than epsilon when z minus z naught is less than delta. Z minus z naught is less than delta. Minus fz naught. So we can write, yes, we can write with the help of this, we can write fz is equal to fz minus fz naught, z minus z naught, z minus z naught plus fz naught. We can write in this manner. Okay. Now taking the limit, z is approaching to z naught. So taking limit, z is approaching to z naught. Fz is limit z is approaching to z naught. Fz naught, z minus z naught, z minus z naught plus fz naught. Fz naught. Okay. So this can be right because we know that function is differentiable. So this limit must be exists and it will be a finite value. And we are denoting generally it by f dash z naught. So limit z tends to z naught, fz minus fz naught upon z minus z naught. In place of it, we can write f dash z naught and limit z tends to z naught, z minus z naught plus fz naught. So when z is approaching to z naught, z minus z naught, its value will be 0. So f dash z naught into 0 plus fz naught. So limit z tending to z naught, fz is fz naught. It is proved. Hence function is continuous. So fz is continuous at this point z0. The function is continuous at this point. So this is the theorem. If function is differentiable, then it must be continuous at that point. But converse is not true. For suppose that function is continuous at a particular point, but it is not necessary. It will be differentiable at that point. But if function is not continuous at point z0, so it never be differentiable at that point. So we can say that necessary condition for function to be analytic at a point z0 if the function is continuous at that point. So continuity is the necessary condition for the differentiability of the function at a particular point. With some rule for differentiation of the function. For suppose that a function fz, we have two function fz and gz. Both the function are differentiable at a point. Both the function are differentiable at this point z0. So addition of these two function and subtraction of these two function is also a differentiable function. So say that it is d by dz, denoted by d by dz. So this function must be differentiable and its derivative will be df by dz plus minus dz upon dz. So if function fz and gz are differentiable, so its addition and its subtraction is also a differentiable function. In the same way, their product fz and dz is also a differentiable function, and its derivative is given by fz g dash z plus f dash z into zz, where this prime is denoting derivative of the function, first derivative of the function with respect to z. In the same manner, their derivative fz upon zz, this it will be also a differentiable function, and derivative is given by zz square f dash z zz minus fz g dash z, provided that this gz is not equal to 0 at that point at z is equal to z0. जिस भी point पर differentiability check कर रहे हैं, this denominator should not be equal to 0. Then only we can say that their ratio या quotient will be a differentiable function at that point. Okay, so one example for this example for function is continuous but it is not differentiable at a point. So example is show that a function fz z bar, this function is continuous at 0 at but not differentiable at z is equal to 0. But it is not differentiable at z is equal to 0. Okay. So you know that z can be written as z is equal to x plus iy. So its conjugate is z. Its conjugate z bar will be x minus iy. Okay. So function is z bar. So function is z bar. It is x minus iy. So a small increment in this z is denoted by delta z. It must be equal to in small increment in x plus small increment in y. So mod its conjugate is also denoted by delta x minus iota delta I. So if we are talking about the continuity of this function, so mod of z bar, you can see that its real part is x and imaginary part is minus y. Both are the real variables, and these variables are continuous everywhere, so they are linear combination x minus iy. It is also continuous at every point. So if it is continuous every point in the finite complex plane, so it must be continuous at x is equal to 0. It is all must be continuous at z is equal to 0. Fz is obviously x minus iy, where real part is x, imaginary part is y. X and y belongs to set of real number, and it is continuous for every x and y in R. So x minus iota y is also is continuous everywhere in finite complex plane. So obviously fz is continuous at z is equal to 0. Now we will discuss about its differentiability at this point z is equal to 0. Okay, so limit delta z approaching to 0, f of z naught plus delta z minus f of z naught divided by delta z. If this limit exists, then we can say that the function is differentiable at this point. Here our z naught is 0. So this limit must be delta z approaching to 0, f of delta z minus f of 0 upon delta z. F of 0 is 0 here. So limit delta z approaching to 0. This will be delta z bar upon delta z. Delta z bar upon delta z, which can be write as delta tends to 0, delta x minus delta y, and delta x plus I delta y. Okay, so we have to take this delta z is tending to 0. When delta z is tending to 0, this will give us delta x is tending to 0 and delta y. Simultaneously, both are tending to 0. So here we are choosing the path. First, we are taking delta y is tending to 0, and then followed by the limit delta x is tending to 0. So we can write delta x tends to 0, delta y tends to 0. तो पहले हमने ये लिमिट ले ली, डेल्टा y is approaching to 0, then we are choosing the part delta x is 0. So delta x minus I delta y, delta x plus I delta y. So first we are taking this limit, delta y is approaching to 0, it will give us 1. It will give us the value 1. But if we are choosing the path, either of choosing this path, we are taking the limit. First, delta x is tending to 0. First, we are taking delta x is tending to 0, then delta y is tending to 0. We are choosing a path like this. For suppose that first delta x is tending to 0, then delta y is tending to 0. So limit will be delta y tends to 0, delta x tends to 0, delta x I delta y, delta x plus I delta y. So when delta x tending to 0, we will get minus iota upon delta y upon I delta y. This will give you minus 1. So you can see here, if we are choosing different path for approaching to this 0, delta z tends to 0, so we are getting the different limit. So here we are getting the different limit. So we can say that limit does not exist. And if limit does not exist, it means that function is not differentiable. At this point, z is equal to 0 simply. So function fz is equal to z bar is not differentiable at this point z0.
मैम वो एफ डेल्टा जेड बार कैसे हो गया?
मतलब
मैम वो लिखा नहीं मैम, एफ ऑफ डेल्टा जेड से मैम वो अगली लाइन में डेल्टा जेड बार हो गया था मैम, वो कैसे हुआ?
ये वाला ये पूछ रहे हो ना?
यस मैम.
Okay. It is given that function is fz is equal to z bar. ठीक है. So if in place of this z is delta z, it must be delta z bar. होगा ना?
यस मैम, यस मैम, आ गया.
तो बस फंक्शन की वैल्यू वहां पे रख दी. एक्चुअली ये जो फंक्शन है ना z बार, दिस फंक्शन इज नॉट ओनली एट 0, इट इज नोवेयर डिफरेंशिएबल इन द कॉम्प्लेक्स प्लेन. 0 ही नहीं, बाकी किसी भी जगह पे ये हमारा डिफरेंशिएबल नहीं होता है कोई भी पॉइंट के लिए. अभी एक नेसेसरी कंडीशन हम बता देंगे जिसे बोलते हैं हम Cauchy-Riemann equation, in short CR equation. This is the necessary condition for the function is analytic differentiable at a particular point. तो वो necessary condition होती है. इसका statement of proof भी पूछा जाता है जनरली. तो अभी तो खैर नहीं हो पाएगा, कोई एक एग्जाम्पल ही देख लेते हैं. एक एग्जाम्पल और डिफरेंशिएबिलिटी का देख लेते हैं. नेक्स्ट टाइम जो है वो CR इक्वेशन, नेसेसरी एंड सफिशिएंट कंडीशन फॉर फंक्शन टू बी एनालिटिक एट अ पॉइंट, उसके लिए हम नेक्स्ट में पढ़ेंगे. वो थ्योरम हमें प्रूफ भी करानी होगी क्योंकि वो पूछी जाती है. और हाँ, आज एक टेस्ट हुआ था, नेक्स्ट फ्राइडे को फिर सेम टाइम. अब जो टेस्ट का जो कंटिन्यूएशन वही रहेगा, हम 2 बजे से नहीं लेंगे, वही 1:05 या 1:10 से स्टार्ट करेंगे. और नेक्स्ट टाइम जो होगा वो एनालिटिक फंक्शन तक टेस्ट में पूछा जाएगा. ठीक है. ऑलरेडी मैंने इसके क्वेश्चंस वगैरह डाल दिए हैं, असाइनमेंट्स भी डाल दिए हैं और ये भी डाल दिया है, क्या नाम है, नोट्स वगैरह भी इसमें आपके MS टीम में अपलोड कर दिए हैं. ठीक है. तो नेक्स्ट सेम फ्राइडे को हम एनालिटिक फंक्शन जो है टिल एनालिटिक फंक्शन आपका पूछा जाएगा टेस्ट में. ठीक है. उसके बाद नेक्स्ट क्या होगा वो नेक्स्ट वीक के बाद ही बताएंगे. ओके. सो एक क्वेश्चन और कर लेते हैं, अभी थोड़ा सा टाइम है हमारे पास. शो दैट फंक्शन fz is equal to mod of z square. This function is differentiable only at z is equal to 0. This function is differentiable only at z is equal to 0 and nowhere else. Nowhere else. जैसे fz upon z bar, ये फंक्शन जो है, ये फंक्शन is nowhere differentiable, but this function is differentiable only a single point z is equal to 0, but nowhere else in the complex plane. So fz is mod of z square. This can also be write as z into z bar. We can write it like z into z bar. So we have to show that the limit delta z tending to 0, z plus delta z minus fz upon delta z. If this limit exists for every z, then we will say that function is differentiable everywhere. And if it is exists only for a single point z is equal to 0, then we will say that function is differentiable only at this point z is equal to 0 and nowhere else. So okay, let's try to solve it. Limit delta z is approaching to 0. Okay, so in place of z plus delta z, we can write here z into z bar. So z plus delta z, z plus delta z bar minus z into z bar divided by delta z. Okay, so try to solve this product. Limit delta z tending to 0. This is delta z. It will be z into z bar because z plus delta z bar is equal to z bar plus delta z bar. So z into z bar, z into delta z bar plus delta z bar into delta z plus delta z into delta z bar minus z into z bar. Limit delta z tends to 0. Z into delta z bar upon del z plus z bar plus delta z bar. So for z is equal to 0, for z is equal to 0, if we are taking z is equal to 0, तो obviously z bar will be also 0. अगर हम यहाँ पे consider करते हैं z is equal to 0, so z bar is obviously 0. So z bar is 0, it means that this term will be 0 because z we are taking z is 0. तो first term 0 हो जाएगा. Obviously z bar is also 0. और हम यहाँ पे ले रहे हैं कि delta z is approaching to 0. तो delta z bar is also approach to 0. So for if z is 0, if z is 0, so obviously this limit will be 0. Limit this limit delta z tends to 0, z delta z bar delta z plus z bar delta z bar will be 0. But if z is not equal to 0, z is any point other than origin, so what will happen? For z not equal to 0, limit delta z tends to 0. This was delta z bar upon delta z plus z bar plus delta z bar. Okay. So this will give you delta z tends to 0, delta z bar upon delta z plus limit delta z tends to 0, z bar plus limit delta z tends to 0, delta z bar. So this will give you delta z upon 0, delta z bar upon delta z, and this will be z bar, and this limit when delta z tending to 0, so obviously this will be 0. It is limit. So it is z bar plus limit delta z tends to 0. Now we can write here delta z bar can be write as delta x minus I delta y and delta x plus I delta y. अभी पिछले में भी हमने सॉल्व किया था इसी लिमिट को और हमने दिखा दिया था कि ये लिमिट हमारी एग्जिस्ट नहीं करती है. इफ डेल्टा z टेंड्स टू 0, दिस लिमिट डज नॉट एग्जिस्ट. एक बार दिखाया था इसकी वैल्यू 1 आई थी, अदर टाइम इसकी वैल्यू -1 आ गई थी. ओके अभी जस्ट बिफोर हमने जो एग्जांपल किया था उसमें सेम यही चीज मिली थी जिसको हमने दिखा दिया था कि इसकी लिमिट एग्जिस्ट नहीं करती. या आप इसको इस तरह से भी ले सकते हैं. फॉर सपोज आपने एक पाथ ले लिया, एक पाथ सपोज कर लिया कि y is equal to mx. You are getting close to this delta z tends to 0 along this path. Y is equal to mx. So corresponding to this y, change in y will be m into, because this m is constant, delta y is equal to m delta x. You can also use this quantity. So here you can substitute. When delta x is tending to 0, obviously delta y will tends to 0, and when delta x and delta y simultaneously tending to 0, it means that delta z is tending to 0. So we can replace this limit by delta x is approaching to 0, and in place of delta y we can write here m into delta x plus I m into delta x, taking this delta x common from numerator and denominator and cancelling them, we will get limit 1 minus iota m 1 plus iota m. And you know that for different value of this m, this y is equal to mx will be denoting a straight line, different straight line passing through the origin. So for different value of m, value of this limit will be different. It means that along the different path we are getting different value of this term, limit of this term. So obviously limit does not exist, or if limit does not exist, it means that function in this limit does not exist, means it means that function fz is equal to mod of z square is not differentiable anywhere, because यहाँ पे जो z था it is any point other than 0. So for z not equal to 0, function is not differentiable. It means that we can say that function fz is equal to mod of z square is differentiable only at one point, and that point is origin. Okay. So for today, I am ending this class.
Excuse me, ma'am.
Yes.